This video will be an introduction to complex numbers. Since we cannot solve an equation of the form x squared equal -1, because anytime you square a number, you'll get a positive. But since we can't solve this equation by using just a set of real numbers, we have to extend the set of numbers that we use to solve equations to include the imaginary unit I. The definition of I is equal to the square root of -1. Therefore, if you square both sides of this equation, you'll also get I squared is equal to -1. This new set of numbers, called the set of complex numbers, also extends the concept of graphing a number from the one-dimensional real number line to the two-dimensional complex plane. Any number of the form a plus bi is a complex number. So if we look at the complex number 2 plus 3i, this term of the complex number is the real part, and this part, or this term of the complex number, is the imaginary part. We can write all of our real numbers in this form. For example, the number 5 can be written as 5 plus 0i. So the 5 is your real part, and then the 0i is the imaginary part. But a is 5 and b is 0. If we look at the pure imaginary number 4i, that can also be written in this form, but this time the real part is 0, and then the imaginary part is 4i. Two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. We can use the property square root of x times y, where x times y is the radicand, is equal to the square root of x times the square root of y. We can use this property to write the number square root of -a as the product of two radicals, square root of -1 times square root of a. Then we can substitute I for the square root of -1 and simplify the other radical if needed. So if we were asked to write as the product of a real number and I, the square root of -55, we can break that square root of -1 away from the square root of 55 using this property. And then the square root of -1 we would write as I. So then we have I times the square root of 55. Now square root of 55 cannot be simplified any further because we need to look for a perfect square as a factor of this radicand. And this number factors into 5 times 11, which neither one of those are perfect squares. Do another example. Again, we have the negative under the radical, so we'll want to separate that away from the 81. So we have square root of -1 times square root of 81. The square root of -1 is defined as I, and then the square root of 81 we know is 9. Now usually the coefficient, the numerical coefficient, is written in front of the variable. In this case, I is not a variable, but we can treat it the same way. So we would write this as 9i. One more example. We have a negative under the radical, so we'll separate that out. We have the square root of -1 times the square root of 98. Now we need to check to see if 98 has any perfect square factors. So I'm going to come over here and do a factor tree. 98 is the same as 2 times 49, and there we have a perfect square. So let me change this product to I, first of all, because square root of -1 is I. And then square root of 98 I can break into the square root of 2 times the square root of 49. We can't simplify the square root of 2, but we can simplify the square root of 49. So this is I times root 2 times 7. Square root of 49 is 7. Now the final step here, usually your numerical coefficient is written first, and then often the I is next, and then the radical 2. If you put the I in back, you've got to be real careful that it doesn't sneak in under the radical. So usually it's safer to just put it in front of the radical.